All right, so let's get started with the Maclaurin series. So, it's chapter 24. Thank you. So, what is the Maclaurin series and why do we do it? It's really sad that she asked me a question just before the class started. Like, why do you do this? We'll learn that why in a second, but let's just first think about what it is. What is it first? Maclaurin series is a way of approximating, okay? Approximating an existing function using polynomial function. We'll talk about why we approximate things later, but first let's see just a brief example of it. Let's say we have a natural function, e to the power of x. Do you like e to the power of x? I personally, I love e to the power of x, but it's not as easy as polynomial function. So apparently, on the formula booklet, it says the Maclaurin series for the e to the power of x is 1 plus x squared over 2 factorial plus dot dot dot. You see that on the formula booklet. You don't need to memorize something. Probably the dot 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 is x power of n over n factorial. And it just takes a couple of decimals just to see if it's actually true. I'll just show you graphically on my phone. Sadly, screen sharing is kind of weaker now. So if I go y equals 1, I have a horizontal line. Does that look like e to the power of x? Obviously not. But if I put plus x, does that look like e to the power of x? Probably closer, but no. So we put plus x squared divided by 2 factorial. Does that look like e to the power of x? No. So let's go further. Plus x power of divided by 3 factorial. Does that look like e to the power of x? And when we repeat this process, it goes close and close and close to e to the power of x. So basically the answer is apparently it works. But how do we get that? How do I look at e to the power of x and come up with 1 plus x squared over 2 factorial? And how do I, if I give you another random function, how do you make a Maclaurin series of it? So that's why we have the formula for that. If you have a Maclaurin series for f of x, it's given as, once again, no need to memorize such thing. You see it on the formula booklet. It's f of 0, this constant term, plus x f prime of 0, plus, I think it's x squared, is it? X squared over 2 factorial, and f double prime of 0, and so on. That's exactly what you see on the formula booklet. You take an f of x, and you can make a Maclaurin series using this formula. If you ever want to go further, well, we can say it's x power of n over n factorial of f to the power of, no, not f to the power of n factorial of 0. It looks complicated, I understand. It looks complicated, but if you take a close look at it, what is f of 0? Does that include a variable? No. It's a constant value that we can compute. What about f prime of 0? Is that a variable or a constant value? It's a constant value. What about f double prime of 0 or f n prime of 0? All of them are just constant values. N factorial, is that a constant value? Yeah, that's just a number. So altogether, if I rewrite it, I'll show you in another format. You can another format. I can write it as f of 0 plus f prime 0 of x plus f double prime 0 divided by 2 factorial x squared plus f n prime of 0 divided by n factorial of x prime n. The way I wrote it here, now I just have a polynomial functions with scalar coefficients. And the variable is just 1x squared x prime. I really hope that this makes the Maclaurin series a bit more edible. So you can actually swallow it, not be choked on it. Right? The only problem here then is, obviously, the only problem is calculating the f prime of 0 and f double prime of 0 and f n prime of 0. So it is a long work. We just have to differentiate. But I'm pretty sure at this point you realize, is differentiating harder or is integrating harder? Integrating is much harder. Differentiating, it seems like, oh, I can just do it in my sleep. We're just doing that repeatedly. So hopefully it's not too bad. Now let's quickly look at the e power of x version. You notice that e power of x basically just doesn't have f n prime of 0. Why do we know that? Well, e power of x, derivative of e power of x is e power of x. Second derivative of e power of x is e power of x. It's always e power of x. And you take a 0 of it, e power of 0 is always 1. So that's why it's just always 1, 1, 1, 1, 1. So we don't actually see the 1s here. Okay? So let's try a question now. Oh, I can't copy and paste it. If I'm using this screen, I'll need to write it. So, because I'm already using the Snip and Sketch app, I can't use that again to take a picture, a screenshot of it. So my f of x is equal to 1 over 2 plus x. So the question is, can I find the Maclaurin series representation of this function? So what do I do first? Before you start putting into the Maclaurin series formula, I think it's wiser if you if you differentiate things first. Okay. So let's find the first derivative of f of x. What happens if I differentiate this thing? Well, 1 over 2 plus x is basically 2 plus x power of negative 1. What happens if I differentiate that? I get negative 1, 2 plus x power of negative 2. Is there any chain rule for this? Luckily, no. Well, there is, but it's multiplied by 1. What about second prime of 0? No, second prime of x. can see that negative 2 times negative 1 is positive 2 now. 2 plus x, negative 2 goes down to negative 3. Can I do one more? Why not? F triple prime of x is equal to, then, negative 3 times 2, negative 6, 2 plus x power of negative 4. Oh man, oh man. Well, we'll pause there. Am I actually interested in f prime of x and f double prime of x and f triple prime of x? No. What am I interested in? That of 0. Right. So, what is f prime of 0? Negative 1 times 2 plus 0. So 2 to the power of negative 2, which is 1 over 4. So I think it's going to be negative 1 over 4. Let's also find f of 0, which is 1 over 2. Well, what about f double prime of 0? 2 over 2 to the power of 3. 2 over 2 to the power of 3? 1 over 4, isn't it? And f triple prime of 0, 2 plus 0, 2 to the power of negative 4. What is 2 to the power of 4? 16. So it's negative 6 over 16, which is negative 3 over 8. I just literally just plugged in 0. Plugged in 0. Plugged in 0. You just have to spin your head fast. Now, my ingredients are all ready to serve. Should we plug it into the formula? F of x is equal to f of 0, 1 over 2, plus x f prime of 0. F prime of 0 is negative 1 over 4. So negative 1 over 4 x. F double prime of 0 is 1 over 4. 2 factorial is 2. So that's, well, okay. First round, I'll just write it as it is. The next one will be x cubed over 3 factorial times f triple prime of 0, which is negative 3 over 8. Now, it looks a bit complicated, but, it's just numbers and numbers. 3 factorial, maybe I could have computed that right away. It should be 6. So, let's reorder things. Let's say 1 over 2 minus 1 over 4x. And then what about negative 1 over 4 times divided by 2 will be negative 1 over 8x squared. Isn't it? Thank you for catching that. And then my next term will be minus, well, 3 and 6 are cancelled out. So it's 1 over 2, so it's 1 over 16. What I just did is I represented this 1 over 2 plus x as a polynomial function. Why do you do this? Well, differentiating 1 over 2 plus x is easy. Perhaps, right now it's an example question, so it's easy, but perhaps the given f of x may be difficult to integrate. Maybe impossible. Well, this one is definitely possible, ln 2x, or ln of absolute value of 2 plus x, but this one may be difficult. However, what about this one? Is this difficult or easy to differentiate, and integrate. It's very extremely easy. It's just four limit. How we write this is we call it, with this special notation, m sub to 4 of x. Or would it be 3? Let me check. I think we need to go one step further into R. So right now it's 3. Actually, my bad. What it means is, this is third degree Maclaurin series of f of x. That's what this notation means. Third degree Maclaurin series of x. Okay, so today we're just introducing the idea of Maclaurin series. By the way, long time ago, about 10 years ago, when I was graduating high school, we did the Maclaurin series. There's another series called Taylor series. Maybe you've heard about the term. No. Taylor series is not in our curriculum anymore. But the main difference between the Taylor series and the Maclaurin series is, for a Maclaurin series, we put f of 0, f prime of 0, f double prime of 0. Taylor series is f of a, f prime of a, f double prime of a, and derivative of a. So it's not 0, it's a value, so it's to another point. So things are more complicated. Right now, finding the 0 is pretty straightforward. Just 2 plus 0 is 2. But imagine doing 2 plus a all the time. Anyways, so that's it for today. Or not, that's it for now. Afternoon, we'll be continuing on.